Section 7.2, the quadratic formula. Consider ax squared plus bx plus c equals 0, where a is greater than 0. Now solve by completing the square. Ax squared plus bx plus c equals 0. In order to complete the square, we first have to isolate the x squared and the x term. We need to get rid of that c on the left-hand side. We'll do that by subtracting c from both sides. Once we have subtracted c from both sides, we need for our x squared to have a numerical coefficient of 1. We do not want that a there. We can get rid of it by dividing everything by a. That gives us our 1x squared, which we like, plus b over ax equals negative c over a. We're ready to complete the square. In order to do that, we want to take our x numerical coefficient, which is b over a. We want to take half of that, which is b over 2a, and we want to square that. That's our magic number that we're going to add to both sides. Add b, the quantity b over 2a squared, to both sides. We have now completed the square. We want to, on the left-hand side, factor that into a perfect square. That'll be the quantity x plus b over 2a squared. On the right-hand side, we want to combine these two. Let's go ahead and square b over 2a. That's b squared over 4a squared. We want to find a common denominator on the right-hand side. So we're going to use 4a squared as the common denominator. This c over a is missing a factor of 4a. We'll multiply numerator and denominator by 4a. That will give us x plus b over 2a quantity squared equals b squared minus 4ac over 4a squared. Now we need to take the square root of both sides. When we take the square root of the right-hand side, we want to be careful and take the positive and negative square root. So we're getting closer. We can now solve for x. We'll subtract b over 2a from both sides. That will give us our negative b over 2a plus or minus the square root. Let's take the square root of the numerator and the square root of the denominator separately. That leaves us the square root of b squared minus 4ac in the numerator. And the denominator, the square root of 4a squared, is 2a. We can combine those fractions now that they have a common denominator of 2a, and that leaves us with x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is the quadratic formula. So whenever you have an equation of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0, you can solve it with the quadratic formula. One way to memorize the quadratic formula is with the song Pop Goes the Weasel. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. There's a video on YouTube if you want to hear somebody sing it. Note that the quadratic formula can have 0, 1, or 2 solutions. You can tell which one of those cases is true by looking at the discriminant. The discriminant is b squared minus 4ac, and that is called the discriminant. The discriminant tells you how many and what type of solutions you might have. If the discriminant is less than 0, if it's less than 0, you have 0 real solutions because you're trying to take the square root of a negative number. If the discriminant equals 0, then you have 1 real solution. If the discriminant is greater than 0, you will have 2 real solutions. So remember to solve the quadratic equation, you have to have, using the quadratic formula, you have to have the equation in standard form, ax squared plus bx plus c equals 0. Write it in standard form, identify a, b, and c, substitute a, b, and c into the formula, and simplify. So now let's solve these problems using the quadratic. Our first problem, we have 2x squared plus 7x minus 5. It's in standard form, so we want to identify a, b, and c. We want to put those into the quadratic formula. Remember, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So using our values of a, b, and c, and whenever I insert negative numbers or substitute negative numbers into a formula, I always use parentheses. So it's negative 7 plus or minus the square root of 7 squared minus 4 times a times that negative 5. Use parentheses around negative numbers. It'll help you keep your signs straight. All over 2a, and a is 2. So it's negative 7 plus or minus the square root of 49. 4 times 2 is 8. 8 times negative 5 is negative 40. So it's minus a negative 40. Keep those signs straight. All over 4. So it's negative 7 plus or minus the square root of 89 all over 4. And that's our solution. You cannot simplify the square root of 89, so that's our solution. Let's work this problem. It's in standard form. Let's identify a, b, and c. A is 3, b is negative 8, negative 8, and c is negative 7. So let's substitute those into the quadratic formula. I'll use parentheses around the negative numbers. So it's negative 8 plus or minus the square root of negative 8 squared. We need to put that negative 8 in parentheses because you're squaring the quantity negative 8 minus 4 times a times c all over 2a. That gives us a positive 8. What do you get when you square negative 8? Positive 64. Minus, what's 12 times negative 7? Negative 84. All over 6. Minus a negative 48, minus a negative is the same as plus a positive. So it's 148. All over 6. I think we can simplify the square root of 148. Let's do that. Come over to the side and think about 148. It's divisible by 4. So let's factor that as 4 times 30, 32, 28, 37. Square root of 4 is 2. 37 is prime. You cannot take its square root. So we can simplify the square root of 148 as 2 radical 37. So we're going to simplify our answer as 8 plus or minus 2 radical 37 over 6. We need to simplify this. We'd like to cancel. We've got lots of 2's, but you must factor before you cancel. Factor out a 2. Then you can cancel. 2 goes into 6. 3 times. So our final answer is 4 plus or minus the square root of 37 all over 3. And that's our solution. Last problem is not in standard form. We need to rewrite him in standard form. Standard form is ax squared plus bx plus c equals 0. We need equals 0. Let's subtract 6x, subtract 4 from both sides. Let's identify a, b, and c. A is 1, b is -6, c is -4. We must put it in standard form before we identify a, b, and c. So now we can solve using the quadratic formula. X is -b, so it's a -6, plus or minus the square root of b squared, so that's -6 squared, minus 4 times a times c, all over 2a. What's -6? +6 plus or minus the square root of 36 minus 4 times 1 times -4, that's minus and -16, so plus 16 all over 2. 6 plus or minus the square root of 52. (52) is evenly divisible by 4. So let's come over to the side and see if we can simplify the square root of 52. That's the square root of 4 times 13. So that's 2 radical 13. So we want to change this. We have x equals 6 plus or minus 2 radical 13 all over 2. We'd like to simplify this. There's lots of even numbers. So we want to factor out 2. We have 3 plus or minus radical 13 over 2. Now we can cancel those 2's, and our final answer is 3 plus or minus radical 13. So in general, to solve a quadratic equation, we will check to see if it's in the form x squared equals d, or x plus c quantity squared equals d. If it's in this form, we can use the principle of square roots. If it's not in that form, we write it in standard form. Try factoring. Factoring can be really easy. If it's not possible, or if it's just you can't figure out what the answer is, use the quadratic formula. All quadratic equations can be solved with the quadratic formula or completing the square. So let's look at these problems and see if we can apply those rules for solving. So our first problem here, it's not in the form in problem 1, so we can't use the principle of square roots. We can try to factor it. Let's see if we have any luck factoring it. It could be 6x and x. It could be 3x and 2x. It's minus 5, which means we have to have a plus, one's a plus, one's a minus. I don't know which one should be plus and which one should be minus, so I'm just going to guess. -5 can only be factored into 1 times 5. So think about where you put the 1 and where you put the 5. How about if you put the 5 here and the 1 here? That gives you 10x minus 3x. That gives us our middle term of 7x. So this is our factoring solution here. But we have to keep going. It's not our final solution. We have to keep going. We have to set each individual factor equal to 0. Then we have to solve for x. Solve for x in this first one. Subtract 5 from both sides. Divide by 3. X is negative 5/3. Second one, add 1 to both sides. Divide by 2. And you get x equals 1/2. So we have two solutions. This one is written in the form in problem 1 almost. If we divide both sides by 5, we will have x squared equals 11/5. We can use our principle of square roots. Take the square root of both sides. Are we missing something? We need a plus or a minus. This one is not really written to use the principle of square roots in step 1. It's not in standard form. We better put it in standard form. We need equal 0, so let's subtract 2x from both sides, add 3 to both sides. That gives us our equal 0. We can try to factor it, but I don't think we're going to have any luck factoring this one. Let's try the quadratic formula. We identify a is 3, b is -2, and c is 3. So let's use these values in the quadratic formula. Negative b, -2, plus or minus the square root of b squared minus 4 times a times c, all over 2a. That gives us a positive 2 plus or minus the square root of 4 minus 4 times 3 is 12 times 3 is 36 over 6. 2 plus or minus the square root of a -32. What do you think about that square root of a negative number? No real solutions. There might be some imaginary ones, but no real solutions. This one's written in the nice form. We can use that principle of square roots. Let's do that. We can go ahead and take the square root of both sides. Are we missing something? Don't forget that plus or minus. We're trying to solve for x. Let's add 9 to both sides. And that's our answer. Those are easy. Look at this one. We need to clear these fractions. If you were to add these fractions together, you would have a common denominator of x squared. So we're going to multiply everything by x squared. So we have x squared minus x squared times 1 over x equals, the x squares cancel over here and we have a 3. X squared minus, look at this x and the x squared. That x cancels into the x squared and leaves you with x. So it's minus x. We could subtract 3 from both sides, and that would give us equal 0. You might be tempted to factor this. You can try. I don't think it's going to work. So let's go ahead and identify a is 1, b is -1, and c is -3. And let's use that quadratic formula. Negative b plus or minus the square root of b squared minus 4AC all over 2A. That's positive 1, positive 1. What's that last one? 12. So we have 1 plus or minus the square root of 13 all over 2. And that's our solution. That's all for this section.